From the Soggy South studios of Way Happy, that's right, it is raining in California. This is Mr. Meyer and section 5.4. It's more about solving quadratics. This is called completing the square because that's what we're going to get it to. But this is really more about solving quadratics. So let's go ahead and start. One of the nicest things that can happen to you when you're solving a quadratic, you see it's a quadratic because it's got x squared term, but there's no x term. And you're like, what? No x term? That's a good thing because then you can just solve it like regular old algebra where you're not doing anything fancy. You're just moving stuff over. You're like, oh, look, 11 and 59, they should be put together. So I have 4x squared equals, is that 48? And then you're like, I could divide both sides by 4. X squared equals 12 when you divide both sides by 4, if you're wondering what I did there. And then I'm going to square root. Now I'm drawing in the square root, so it's going to be x equals plus or minus the square root of 12, because what did I really do? I square rooted this side, I square root this side. The square and the square root, they're going to cancel each other out, and you're going to have x left over. And on the other side, you're going to have 12. Now that's almost perfect, except for 12, I'm pretty sure can be reduced. That's 4 times 3, 2 times 2. So look at that. I have a pair of 2's, and the poor 3 is still underneath. So x equals plus or minus the 2 came out, and the poor square root of 3 left behind, and there he is. Nice final answer. Now square roots also can luck you out if you know how to factor. Looking at b here, I'm like, hey, wait a minute. Usually I want to get it equal to 0 and solve. But I noticed just luckily that x squared plus 12x plus 36 factors to x plus 6x plus 6, right? The same thing twice. This side factors to x plus 6 squared equals 28. Now that's kind of a lucky thing to notice, but I noticed it, right? I noticed that the factors of 36 that add up to 12 were 6 and 6, and so it actually worked. It factored out nicely. Well, look at that. There's another squaring problem, which is very simple. I can square root both sides. So again, I would square root the left side, and I would square root the right side. And so again, for those of you wondering, I was just like square root, and then the square and the square root cancel. And what am I left with here? I guess I should clean that 48 or that 28 up, but I'm first going to move this 6 over real quick because he's not under the radical. So it's x equals negative 6 plus or minus root 28. Now I want to clean up that 28. What is that? 14 and 2, 7 and 2. So let's see, I got 2's again, and I have a 7. So what is that? X equals negative 6. Now it's not multiplied, so I can't multiply. Plus or minus, I don't know which one we're using. Looks like a 2 root 7 for me. And there is that beautiful answer. All right, let's ask you a question, and we'll come right back. All right, excellent work. Now, if you notice that last example I did, it was really nice because I noticed I could factor that to x plus 6 squared. And that's the whole concept behind completing the square, is you try to make it easy to factor like that. So it's the same number twice so you can square root. That's all they did. So there in the completing the square box you see, but really what's nice to notice is what you will do is you will look at the, you'll have an x squared term that you want to make sure x squared is by itself, no numbers in front. Then you'll look at the x term, and your job will be to take half of that number, which you can see right here, take half of whatever that b number is, square it, and add it to both sides. That's the big trick, right? Or in this case, just add it to one side because there isn't two sides of the equation. But usually we'd have to keep the equation balanced. But in this case, we're just trying to set it up. So it's always half of that b term squared. And then you add that in, and that makes it factorable. You can kind of follow along in that problem. They know that they had 6 in the middle, so half of 6 is 3, squared is 9. That's why they added 9. And now they could factor it to x plus 3, because what adds up to 6 but multiplies to 9 would be 3 and 3. And so that's why that is such a handy-dandy, super awesome solving method. So here's example 2. We want you to set up this so it is a nice binomial, right? So that I can factor it to a binomial that's squared. So again, remember, half the trick here is half the middle. I call it half the middle number, but it's really half the b term and then squared. So you come cruising along, you look right here and you go, okay, what's half of b? So that would be half of negative 14, which hopefully you're saying is negative 7. And then what you do with that number is you take it and you square it and you put it back right there. So the number that the box would be, to be pretty, would be plus 49, because 7 times 7 is 49. So what does that mean? That means if you had x squared minus 14x plus 49, that means your factors would be negative 7 and negative 7, right? The number that you chose, the half the number. So it would be x minus 7 squared, or half that middle number, or half that b term. All right, try it over here. Look at the 9. What's half of that? Nice. Square it. Nice. And that's what you would have. And then you factor it. Oh, wait. You're probably like, that's not funny. Half of 9 is a fraction. I don't want to do. You're right. It's way hard to do odd numbers because they're not pretty. But you know what? The fractions are just as easy. Remember, I'm going to do half of b, which in this case is half of 9, which is going to be, multiply tops, multiply bottoms, 9 over 2, right? And then remember what we do with that? We square it. And what does that get us? Well, squaring is pretty easy. 81 over 4. So that's what we would want there. X squared plus 9x plus 81 over 4. Isn't that gross? But not really. The numbers are nasty, but it wasn't hard. Think of the people that try to do that in decimal. They're like, half of 9 is 4.5. Then squared is, I don't know, I need a calculator. We didn't use a calculator because we used fractions. Way easier. Even that, when they get their dumb answer, they're not even going to know what the factors are. What two numbers multiply to 81 fourths but add up to 9? You think it's a trap, but it's not. Remember, it's right here. It's the thing we squared in the last problem. So it's the thing we squared in this problem. So your factors are x plus 9 over 2 squared. That's it. It's that twice. That multiplies to 81 fourths. That adds up to 9. What? Mind blown. And that's the gist of completing the square. Now we're going to show you how to use it, but that is the idea. So let me ask you a question, and I'll be right back. All right, now let's try this. Good job. We are going to try to put it all together, and you have to try to solve a quadratic equation by completing the square. So there's the little rules, the little setup. You can write those down, pause the video, whatever. But they are, make sure everybody's on one side except for the constants, the ones that don't have a variable on them. They should be on the right side, everybody else on the left. Divide everything by, if there's anything out in front of x squared, divide everything by it, because that's going to cause trouble in completing the square. Step 3. Half the middle number or half of the x term or whatever, square it, add it to both sides. Factor the left side because you just made it factorable. And then square root both sides and move stuff over and you're finished. So here we go. I made a bunch of problems for us to do, and you're going to see that completing the square is a pretty nice way of solving quadratics that are actually pretty hard. So this first one, I want to make sure all the x's are on one side. So I will bring the 12x over. So I subtracted it, but I'm going to leave the negative 20 on the other side. All right, that was step 1. Step 2 is divide everybody by what's in front of x squared, so divide everybody by 1. That's silly. Step 3 is take half the middle number, what I, again, call that middle number. I wish I'd call it the linear term or something. But take half of this, which is negative 6. Square it, which is 36. I'm going to add 36 to this side. I got to add 36 to this side. All right? Now, factor the left side. The left side becomes factorable because you made it. What two things multiply to 36 that add up to negative 12? Oh my gosh, don't think. It was whatever you squared. What did we square? Oh yeah, negative 6. So it's x minus 6 squared, right? That squared is 36. That doubled is negative 12. Oh my gosh, I'm a genius. The right side is 16. And now look at that. That's like that very first example we did, or second example. We square rooted both sides. X minus 6 equals plus or minus the square root of 16. Oh my gosh, I know the square root of 16. X minus 6 equals plus or minus 4. And now let's move that 6 over. 6 plus or minus 4. And whenever you have something that pretty, you can actually solve it, then go ahead and do it. Go x is 6 plus 4, which is 10. And x is 6 minus 4, which is 2. There's your 2 answers. And enjoy. All right, go on to B. Looks a lot more challenging. Hey, look, they didn't put it in the right order. That's annoying. So 3x squared plus 18x equals 45. Now remember, that's step 1. Step 2 is divide anything by what's in front of x squared. Oh, and this time it actually matters. X squared plus, what is that, 6x? And how many times did it go in there? Like 15 times? I think so, yeah. So I divided everybody by 3, which is totally legal as long as you do it to everybody. Now complete the square. Half of that linear term is 3. And remember that, because that's going to be the factor. Squared is 9. I'm going to add 9 to both sides. Now square this side. Well, you wrote down the 3 for a reason. X plus 3 squared equals 24. Square root both sides. X plus 3 equals plus or minus root 24. X, do you want to reduce the square root first? Fine. What is square root of 24? That is 12 and 2, 6 and 2, 2 and 3. Oh my gosh. What is that? I have a pair of 2's. That's it. So that's 2 when it comes out. And under the radical are the people that didn't come out. So 2 times 3 is 6. So 2 root 6. So plus or minus 2 root 6. Now let's move that 3 over. Negative 3 plus or minus 2 root 6. And believe it or not, you are more exact than any calculator. The calculator would have given you a decimal answer, and you gave me an exact answer. That's it. That's completing the square. So I thought, oh my gosh, too easy. So I added a couple more just to see if we could have some fun. Like, look here, half the middle number's 5. It's already set up and ready to go. So half the middle number is going to be 5. I'm going to add 20 something to both sides. Half the middle number is 5. Squared is 25. Add 25 here. Add 25 here. Hey, what number did you just square? Oh yeah, that was 5. So it's x plus 5 squared equals 45. Square root both sides. X plus 5 equals plus or minus the square root of 45. What is that? 9 times 5. Hey, that's 3 root 5. That's 3 and 3, right? So x plus 5 equals plus or minus 3 root 5. Move the 5 over. Negative 5 plus or minus 3 root 5. Why can't I add those together? Because one has a radical and one doesn't. Remember, you have to have the same radical in order to add them together. All right, what about the next one? Oh no, look, the 23 is throwing me off. Move it to the other side. X squared minus 6x equals 23. That's step 1. Get all the x's on the left, constants on the right. Step 2, divide everybody by what's in front of x squared. Okay, divide by 1, we're done. Step 3, take half the middle number, square it, add it to both sides. So negative 3 squared is 9. I'm going to add 9 to both sides. And lo and behold, I have this factor 2x minus 3. Oh, why was I so smart? Because I know it's half the middle number. It's half of negative 6 equals, what is that, 32? Square root both sides, x minus 3 equals plus or minus square root of 32, which happens to be what, 16 times 2, and I know that's 4. So x minus 3 equals plus or minus 4 roots of 2, and x equals 3 plus or minus 4 roots of 2. Are you getting the idea that this isn't that spooky? I mean, I'm flying because it's so much fun. Maybe you're like, slow down. So pause it and go ahead of me or something. But don't be scared. Look here. I got x squared. I got to move the 14x over, so I'm going to bring it to this side. I'm going to move the 13 to the other side, so it's going to be negative. Oh, that was really scary, right? Not really. Half the middle number 7 squared is 49. I got to add 49 to both sides. Why would I do that? Because the left side's factorable now. X plus 7 squared. Remember, it's always half the middle number. Equals, what is that, 36? Square root both sides. X plus 7 equals plus or minus the square root of 36, which I happen to know is 6. That makes my life, you know what it makes it? Way happy. Move the 7 over. Negative 7 plus or minus 6. Okay, this is a pretty one, so I'm going to do our two answers. Negative 7 plus 6 is, I should write x equals negative 1. And negative 7 minus 6 is x equals negative 13. Are you kidding me? I'm just knocking these quadratics out with a little thing called completing the square. Have a nice day. Stay happy, and I'll see you tomorrow.